G'day and welcome to Divers Cove, where weather's always sunny and clear and you get at least 20 meters visibility. I know, I'm dreaming. Online I go by Zentisca. I'm a scuba diving instructor, recognised by multiple organisations. Today I want to make a quick video about dive tables in general, so let's get into it. There's many different types of dive tables out in the world. Most will be familiar with the PADI Dive Tables, while some solely rely on dive computers. While there's nothing wrong with just using dive computers, there's no better feeling than the reassurance from a physical dive table. It's the diver's version of a warm blanket, just with many more pressure calculations. For example, if you wanted to plan a multi-level dive, or in some cases multiple dives in advance, some dive computers aren't going to give you that information pre-dive, but what they will do is they'll beep at you after you've made a mistake, just like your passive aggressive roommate. And it's this reason why I think learning at least one dive table is important. At the very least, is to have confidence in your dive plan. There are two key things to take into account when it comes to dive tables. Well, technically three, but panic isn't officially listed. The first is the most common, which I'll mention here, being the maximum dive time for a given depth. And secondly, what these dive tables are actually based off of, which is nitrogen buildup. Just for a really quick crash course, the standard air mixture is 21% oxygen, 78% nitrogen, and 1% other. That 1% is mostly noble gases, and whatever gas adds buoyancy to your wetsuit unexpectedly. So this 21% oxygen, 78% nitrogen, and 1% other is the air that we breathe on a day-to-day basis, and that's the standard that's compressed into our scuba dive tanks. As you go deeper, the pressure increases, and that means the partial pressure of the gases you're breathing, like oxygen and nitrogen, also go up. Just like your Tinder date, the deeper you go, the clingier it gets. When it comes to partial pressure, we call oxygen PO2 and nitrogen PN2, and it's actually the reason why we have dive limits in the first place. Simply put, the deeper you go, the more oxygen and nitrogen you breathe in one breath compared to as if you were breathing on the surface. The oxygen you breathe in is equally exhausted out from your lungs, carrying away the waste gas, carbon dioxide, while nitrogen on the other hand isn't equally exhaled. It's this unequal exchange that leads to all the restrictions we have in the real world of diving. Granted, it's a bit of an oversimplification, but true for the most part. But hey, this isn't a physics PhD, I'm just trying to make sure you don't become a human soda stream. What ends up happening is that some of the nitrogen that you inhale gets absorbed into your bloodstream and then spreads into different tissues in your body, such as muscle, fat, and bone. And there needs to be a way to calculate this nitrogen buildup, and that's how we start to see dive tables being formed. All dive tables take into account what's called body compartments. The body compartment model comprises of several sections splitting the body up into different parts to easily manage the calculations of which parts remove their nitrogen faster versus which parts remove them slower. For example, muscle gets rid of nitrogen buildup quicker than what fat does. The PADI dive table, however, uses a one body compartment system, which is called a 60-minute half-time tissue. I'd be lucky to hit 6 seconds. And while this doesn't give you the longest time at a given depth compared to other tables, it's done to be conservative, meaning that it's rather safe to use, and that's really good practice for diving in general. So I guess less exposure time pays off for being safe, huh? Good to know. It's also why a lot of instructors, and myself included, will often use PADI dive tables as it's easy to learn, easy to read and use. The nitrogen buildup is also known as residual nitrogen and is often reflected with a letter from A to Z, A being the least amount of residual nitrogen while Z being the highest. There are ways to reduce the residual nitrogen in your body, most commonly seen from surface intervals, but can also come from different gas mixtures such as nitrox. I'll get into different air mixtures in another video, as the standard PADI dive table is meant to be used with standard air. It's also meant to be used as a normal breathing rate. So if you're breathing like an overexcited Labrador, your results may vary. As a good practice, you'll always perform a safety stop near the surface. For PADI, this is the 5 for 3 rule, where you stop at 5 meters for 3 minutes. And this helps dissipate any unaccounted nitrogen that may still be in your body. Other dive tables can use decompression stops, and this helps you to achieve longer and deeper dives, but that's out of the scope for this video. So now we know why we have dive tables, and also why we have these body compartments to track the nitrogen buildup, but how do we actually use one? For this example, I'll be using a PADI dive table. Here, if there's another dive table that you're keen on, or one that you want broken down, drop it in the comments and I'll cover it in a future video. So if we look here at the PADI dive table, at the top you can see depth in meters. On the left we have a line of letters, and this is our pressure groups. At the bottom that intersects these points, we have our time in minutes. Then to the right of that, you'll see that we have some more letters, and further to the right, you can see we have a bunch of small numbers that look jumbled up. While the left side looks nice and clean, the right side can look kind of daunting. But don't worry, in just one example, I can make all of this as clear as the rain. But before I get into it in depth, pun unintended, it's important to note that this is actually two separate dive tables combined to one page. It's our maximum bottom time, which is table 1 on the left, and our surface interval credit table 2 on the right. Let's give a real world example of this dive table in action. Remember when I said earlier about PADI dive tables being conservative? Well, we also plan conservatively too. So if I said that we're diving to a maximum depth of 19 meters, you'll notice that there's actually no 19 meter choice here. So which depth might you actually pick? And remember, you plan your dive to the depth you want to go. Now, this table does come in feet as well. So if you are learning the metric one and you intend to use it for an imperial one, it's completely fine because they are still the exact same thing. The way that you learn the metric one is the same way that you'll learn the imperial one. If you like, take a second to pause the video and see if you can work it out. So if we want to go to 19 meters, we wouldn't pick 18 meters, as this would be changing our maximum target depth. We'd want to go down one column, which takes us to 20 meters. So if our target depth isn't there, just move on to the next number. If we were diving to 20 meters, we would just use the 20 meters one. So if our target depth isn't there, we'd go to the next number on the right. And to get our maximum dive time at that depth, we just follow the column from the top down to the last number. In this case, it's 45 minutes. You can see that 45 is written in a black box. And this is just that way it's easier to see that this is a reminder to you that this is your maximum time at this depth on this dive table. Then above, there's 3 boxes that are gray, and this is to indicate mandatory safety stops. So if you do a dive to 20 meters for 40 minutes or more, you'll need to stop at that 5 meters for 3 minutes to reduce any unaccounted for nitrogen. If we dive to the 45-minute mark, we would have a residual nitrogen pressure group of a letter U, which you can see if we go to the row to the left. If you were to dive for 43 minutes and at 20 meters, well, again, we would plan conservatively. We'd go to the next available number, meaning we'd plan for 44 minutes, giving us a pressure group of T. And that's it. That's how you use table 1. Now, what if we wanted to come up to the surface and reduce our residual nitrogen to allow for a follow-up dive? This is where we look to the table on the right. So we walk our fingers over to the right, and this is where we see our surface intervals. Basically put, the longer you spend on the surface, the less amount of residual nitrogen will be in your system. We just simply follow the arrows to help guide us with the flow. So the first box says 000 to 002 is saying that if you spend a maximum of up to 2 minutes on the surface, and if we follow the column down to the arrow, you'll still be at pressure group T. But if we spend 3 to 6 minutes on the surface, we'll be promoted to pressure group S instead. And again, that's how you use table 2 really easily. So we can get our maximum dive time at a given depth, and then we can work out what our pressure group will be after we spend some time on the surface. Maybe we might want to have some lunch between dives or something, which will be up there for 20 minutes. And this is how you can calculate all of that. Now, table 3. If we flip the dive table over, you'll see table 3, which is used to help calculate repetitive dives. And yes, there's more, because diving is equal parts fun and equal parts homework. I'm not going to go into this table in this video because I'd actually like to go in more depth with this, and it really deserves its own video for its own breakdown. When that video is ready, I'll pop it in the video description, so be sure to check there for part 2. I'll probably end up doing a recap for tables 1 and 2 quickly, but that next one will be a full walkthrough of the PADI repetitive dive table. So you'll be able to do your PADI repetitive dive planning, and it'll be a more focused video just for the PADI dive table. Whereas this video has been more about the background behind why we actually have dive tables in the first place and what our restricting limits are for the diving well, which again is the nitrogen buildup. Since this video was meant to be just about dive tables in general, I don't want to needlessly rush a topic and potentially end up confusing anyone. In the world of dive tables, there are many out there. Some are easier to read and some are easier to use, and some having a wider case use, while others are more specific to different types of diving, such as diving at altitude, where you go up a mountain and you enter a body of water up there because the rules of nitrogen there are different to what you are at sea level. Thanks for sticking around to the end. Hopefully this gave you a quick overview of everything and explained why we actually have dive tables and a little bit about the nitrogen. I'm going to be doing a video more about the nitrogen buildup to go into more depth about it. So if you're a little bit confused of how nitrogen interacts with your body, that's going to be the video dedicated to that. Feel free to drop down any dive tables that you'd like to have broken down, or any topics related to diving that you'd like to hear about. I spent the last 3 years teaching myself to program so I could make my own dive app. While I've got it near completion, I'd love to hear some features that you'd be keen on, anything that you'd like to see included. If you want to learn more about diving, be sure to check out my playlist on my channel. This is going to be the first entry into that playlist, but of course, as I do more videos, more will be uploaded to that playlist. Anyways, till next time, see ya.